Welcome to solverfy.
Okay, in this problem, we're asked to find the square of the wave function given as some time-independent portion, or multiplied by a sine function. Oh, and there's no square on this yet. So this is just a sine function varying in time. We're asked to find the square, and we can assume that this amplitude, little psi, is just a function of x only, not a function of time. And after we find this square of the wave function, we're asked if this is a stationary state. And recall that a stationary state is defined as one in which all the observables we could collect from it are time independent. So let's first take this square. The square of our wave function is really just going to be the square of the time independent part and the square of the sine function. So it's relatively straightforward. Ordinarily, if we had some complex numbers, complex valued quantities, we'd have to multiply by the complex conjugate, which is slightly more complicated, but this is pretty straightforward. So really, we just have the time independent part squared multiplied by the sine function squared. So taking a look at this, we see that, well, first of all, we can say there's one observable, and that's location, probability of locating a particle, the position of a particle, described by this wave function. It is just simply defined as the square, the complex conjugate multiplied by the wave function. This square, which is what we just computed, which is clearly a function of time. It's a function of time because of this sign. No matter how we square this or what we do to it, we cannot eliminate the time independence. So we have an observable, the probability of locating a particle at a position, which is clearly a function of time. Thus, this cannot be a stationary state. For a stationary state, all observables must be time independent. And we just have shown that there's one that's clearly not. And that's it.